Good afternoon.
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 Okay, so I want us to discuss on project appraisal and risk. So far, you'll be making one common assumption that, hey, when it comes to the appraisal of investment, whatever is a focus, don't forget, we need to say that when we are doing the calculation, for example, of the NPV, we in the focus, the analysis was done as per today, in year zero today. Okay, we made a forecast that in year one we forecast the cash flow we'll be getting is X amount. Okay, year two X. Okay, year two Y. Okay, year three Z. Okay. So generally, we did assume that whatever was the amount you were to receive, okay, is going to the amount you are expecting is what you're going to actually be receiving. Okay, that's an assumption which you didn't make. But the reality is that that might not be the case. There could be instances where the actuals, okay, the actual cash flows, for example, you'll be getting might be different from what you are expecting. Okay, that's going to be the reality. Okay, you expect as per the plan, the plan was to get 10 million cash flow in year one. The reality, you may get, for example, 3 million, okay, or 8 million, 9 million. Okay, that's the reality. Okay, so therefore, how therefore do we appraise? Okay, how therefore do we therefore incorporate those risks? Okay, the chances of maybe the focus being different from the actual. Okay, how therefore do we incorporate risk in project appraisal? Okay, that's the next subtopic. Okay, that I want us we discuss regarding the appraisal. Okay, how therefore do we incorporate risk when it comes to project appraisal? Okay. Generally, we're going to be assuming or call risky environment, not uncertain environment. Okay, but what the difference with the two, risky environment and uncertain environment? A risky environment, this is going to be cases, okay, where maybe the cash flows that you are expecting to receive, okay, the outcome, okay, there are going to be several set of possible outcome, okay, not just one outcome like what you've been doing so far. If in year zero, if it was 10,000, we assume that you only have one outcome to get 10,000, nothing else, okay. But the reality is that you may get maybe 8,000, you may get maybe even more sometime, okay. So there'll be several set of possible outcomes that can occur. Okay. So in case we have several set of possible outcomes, then we're either in a risk situation or uncertain situation. In case we have experience, in case we have the knowledge, okay, based on our past experience with the project, okay, based on the available data. So in case you have the data, you have the experience, okay, to be able to assign probabilities to those set of possible outcomes, okay. If you have the experience and you can be able to assign probabilities to the set of possible outcomes, okay, then refer to them as what we call is a risky environment, what we call risk, okay. You can have, or it is possible for you to have several set of possible outcomes, and those outcomes you can be able to assign probabilities, okay, called a risky environment. In uncertain environment, okay, there are several set of possible outcomes. Okay, you'll be getting something different from what you are expecting. Okay, however, you don't have enough experience to be able to assign probabilities to those outcomes. Okay, therefore uncertain environment. Okay, that's you have several set of possible outcomes. Okay, however, you don't have experience to be able to assign probabilities to the set of possible outcomes you can have. Okay, that's on a risk uncertain environment. That is the risk and uncertainty. Okay, so don't forget that both of them, there are several set of possible outcomes that can occur. But the difference is, can you assign probabilities? If you can, then go risky environment. If you can't, then go uncertain environment. Clear? Okay. Another key distinction that we have mentioned regarding risk and uncertainty.
Sorry, just kindly go back to the previous slide a bit. Okay, thank you.
Okay, the key distinction between risk and uncertainty. Okay, how is clear because there's a time examiner is going to ask you. Okay, to
Sir,
explain. Yes, yes.
I don't understand the last point for both of them.
When it comes to risk, okay, when it comes to risk, the risk is going to increase in line with what we call the variability of the return from what you're expecting. For example, let me just give a very simple example. Assume that these are the return that you are anticipating to get. Okay, assume that this is the return you wanted to get. Let's say 10 million. Okay, however, you can get let's say 9.5 million, and you can also get, for example, 10.5 million. Okay, because this is what you're expecting. These are the outcomes. Okay. What you mean that when you apply the for, if we are in situation A, we call this A, and you have B, okay, you expect to get 10, you end up getting 3, you end up getting 15 million. Where do you have more risk? A or B?
Could you please repeat your question?
Okay, you are anticipating to get 10 million. In both cases, the 10 million. This is what was the focus. However, the reality that you can get either 9.5 or 10.5, or you can get 3 million, okay, or 15 million. Mm-hmm. Which among the two situations do you have more risk? A or B? Of course, B. But remember, therefore, the variability, the variation. Okay, you can see here the variation is 0.5. Here is 0.5. Here it's 7, and here it's let's say 5 million. Okay, therefore we have more risk. It increases as the variability of time increases. So here you have more risk compared to the case of A. Okay. Then regarding uncertainty, let me explain that. Okay. With regard to uncertainty, assume that we have a project here. You want to carry out a forecast for year 1. You want to determine, therefore, what's the amount you can get in year 1. And for year 10, where do you have more chance of getting it right? Is it forecasting year 1 or forecasting 10 years from now? You want to make a projection, okay? Either year 1 or year 10. So the question is that where do you have more chance that you're going to get it right? A 10-year focus or a 1-year focus?
1 year focus.
A one-year focus, definitely. Okay, 1-year focus. Okay, in case you're forecasting the next few days, it's a bit easier to tell what is going to happen tomorrow. Okay, compared to what's going to happen 10 years from now. Okay, that remember, therefore, uncertainty increases as the life of the project increase. Okay, if you have to forecast tomorrow, it might be raining. That's going to be more certain for sure. Okay. 10 years from now, is it going to rain today? A date like today, you can't tell. It's too far. Okay, because therefore uncertainty increases as the life of the project increases. Okay, in short, there's more uncertainty to those projects that have longer life than those that have a shorter life. Okay, hope that's clear, Nafisa.
Thank you, sir.
Okay, great. Okay, so the number of method you can use. Okay, anyway, you can go through this in case you want this slide. Okay. Now, what can count the appraisal, therefore? Which method do you use that can ensure that we do consider? Actually, when it comes to appraisal, we are going to be considering only a risky environment. Okay, we won't consider uncertain environment. Okay, so this topic, okay, we'll be considering risky environment, not uncertain environment. Okay, so one of the way we can try to incorporate risk in appraisal of the investment is the use of what we call risk-adjusted discount rate. Okay, the use of risk-adjusted discount rate. Okay, now this rate essentially what you're trying to do is that we determine in case you're going to be investing in a highly risky projects. Okay, that is you're comparing with the current project. Okay, what's the risk of your investment currently? It can be 10%. Okay, based on plus or minus. Okay, so what would happen in case we were to invest in a more risky environment? The provider of capital will be expecting higher rate of return. Okay, if you go to the bank will ask you, where do you want to invest the money? Okay, what is the investment? Okay, you want to put your money where? Okay, so the bank can make an evaluation. What's the risk you're going to be assuming? And of course, we charge you interest based on the risk of the project. Okay, that's the reality. Okay, which implies therefore, when it comes to discount the cash flow from a risky project, then of course, therefore, the cost of capital will have to be much more greater than the other projects. Okay, the more the risk, the more the return the providers of capital will be expecting. Okay, the more the risk, the higher therefore the discount rates. Okay, then when discounting the cash flows from this project, we discount them at a higher cost of capital. That's what we want to mean by that particular point. Okay, risk adjusted discount rate. Okay, if you're going to be investing in a less risky projects, okay, whose risk is a bit low compared to the company current investments, then imply therefore the provider of capital will be expecting therefore a lower rate of return. Why? Because the risk of their capital is a bit low because the company has chosen to invest in a lower risk project. Therefore, when discounting the cash flows from this project, we discount them at a lower discount rate. Okay, for the use of risk-adjusted discount rate. You have to compare what is to make a comparison. What's the risk exposure towards the provider of capital for this particular project? If the risk is high, therefore a higher discount rate will be used. Okay, clear? That's the first method, the use of risk-adjusted discount rate. Then you can also use instead of using the payback period, you can also use the use of discounted payback period. Okay, which I think we have done that already. Don't forget, when it comes to the use of the discounted payback period, we have already done the risking operation. Why? Because we have discounted the cash flows from the investments. Okay, and did we discount the cash flows? I'm not sure that we did that in the last question we did. I think we did discount the cash flows, if I remember, by the way. There's a question that we did where we meant to get the payback period, and I guess we didn't discount those cash flows. Anyway, shall go through it again. Okay, if we didn't discount the cash flows, then we need to discount them. Okay, so therefore, instead of using just a payback period, okay, it could be better that you appraise the investment based on their discounted basis. Okay, days of discounted payback period. Okay. Then you have the use of the certain equivalence method. Okay, the certainty equivalent approach method. Okay. Now, in this method, what we do, okay, is that we convert all the cash flows. Okay, all the cash flows to be received. Okay, don't forget to mention that these are risk cash flows. Okay, so the assumption we have is that the company has had a similar experience. Okay, or they have most of them they have a similar experience. Okay, they have made this investment in the previous years. Okay, and this is not a new investment per se. So it's like maybe there is a machine they invested. Okay, they have already had the experience with this machine before. Okay, so it implies therefore they're going to be operating using this machine from point of knowledge. Okay. It implies therefore the cash flow they are anticipated to receive from the investment. Okay, based on their forecast. Okay, need to be compared with the current investment. Okay, let me give you an example. If a company had made a similar investment project, okay, a similar project, okay, and this was in year 2010, 2015, year 2011, year one, that is 1 year later, the cash flow the cash flow they wanted was to get, let's say, 10 million. Year two, to get 1.5 million, to get 8 million. Year 2, 8 million. Year 3, the focus was to get 5 million. Okay, this was the focus then. Okay, but since this is already in 2015, we have the company. This is past, so the company has the actual data. So what's the actual? The reality was the company in year 1 received in 2011. They got, let's say, 8 million. Okay, they got 4 million in year 2, and they got, let's say 3 million. Okay, so it is possible to say like that. Comparing the forecast and the actual is going to be 80% of the forecast, and this is going to be 50% of the forecast in year 2, and this is going to be 60% of the forecast in year 3. Okay, so to imply therefore, if in year 2020 this company want to make a investment in year 2020, 2021, that is 1 year later, 2 years later, 3 years later, in year 2020, okay, if the forecast is, let's say, 20 million, okay, forecast here is, let's say, 30 million, focus here is, let's say, 15 million, that you can see that the forecast, okay, the actuals, because you have the experience, the actual will be 80% of the forecast. Therefore, in the year 2021, what you are certain of getting is therefore 80% of 20 million, therefore we'll be getting 16 million. Okay, here we'll be getting half, which is therefore 15 million. And you'll be getting 60%, which is equal to 8 million, I guess, will be equal to therefore 80 million. Okay, so therefore what we're trying to do, okay, in this particular question, in this particular case, is that we're trying to compare between forecast and the actuals. Okay, these are not actuals as per se. We are call them the certain amount. These are called certain amounts, okay? However, they're based on the previous experience the company had within a similar project, okay? So when you convert all the cash flows, okay, all the forecast cash flow into certain amounts, okay, like we have done here. There we go. Okay, so convert all the cash flows into certain amounts, okay, based on your previous experience you've had with a similar investment, okay. Once we've done that, we have these are called the certain amounts, okay. These are certain amounts. These are certain amounts, okay. Then what do? We now discount them since these are certain amounts. They're not actuals as per se, but these are we are more sure with this what we're going to get, okay. Therefore, you discount them at the risk-free rate of return, okay. Because the risk element here has been stripped off, okay, if you have to say that way, okay, because we are basing our experience for the past projects, okay, so these are not just forecast, okay, these are now certain amount based on the past similar project the company has had investment in. So once you have these cash flows, okay, you discount them at the risk-free rate of return. Why risk-free? Because these are certain amounts. They're not risky amount as per se, okay. And now we get the NPV and determine should we invest or not invest based on the NPV obtained by discounting the certain amounts using the risk-free rate of return. Clear? Okay, great. Let's do an example here. Yes, yes.
Just to confirm, this is the second way to find the risk, right? Like I got my internet connection was bad, so
this is the third
I was
method.
out of it.
The first method is called the use of the risk discount rate. Okay, then we did use the use of discounted payback period. Okay, you can also use this method. Okay, and the third method is the use of the certain equivalent approach method. Okay.
Okay, thank you.
Great. So I want to read a question. So go through this, then we discuss together. Okay, can do this. So in this question, again, all we need is to project. Just a minute. Okay, so in this method, what we need is to project these cash flows. Okay, let's simply convert this risky cash flow, the 4,000, 2,000, 2,000 into certain amounts. Okay, so based on the current NPV without risk incorporation, we got a positive of 1304. Therefore, should we invest in it? Yes. Okay, based on the current without risk incorporation, the company, this seems to be a good investment. But let's see, what if we incorporate that this is a risky investment? Okay, what if we do that? Does it still remain as an investable project? Okay, so we convert all the cash flows into certain amounts. Okay, therefore, so here the forecast cash flow. Okay, so this year one, it can be in year zero, year one, year two, year three. Yes, the 3 years. Okay, these are the risk cash flow. Year one is negative 5,000. Year two, it's 4,000, 2,000, and 2,000. So you convert it into certain amounts. You convert this into certain amounts. You'll be told that based on past experience, year one cash flow will only be 70% of what was forecast. This is year zero. This therefore it's still remains as it is because this is today. However, year one cash flow will be 70% of the forecast. 4,000 times 0.7, and you get 2,800. Year two will be 2,000. We multiply by the conversion rate by the standard equivalent ratio, which is equal to 50%. Give that for 1,000. Okay, then 2,000. Year three, we only get 40% of that forecast, and give that for 800. Okay, so if we have what we call the certain amounts. Okay, therefore we discount these cash flows back using the risk-free rate of return, which is 7%. So we discount these cash flows at 7%, 0.077%. Okay, so discount that by 7%. Okay, and we get the present values. Okay, we get the sum, and the sum therefore will be the NPV. Okay, there was NPV. Then, of course, based on that, the NPV obtained there, we advise the company.
Sir?
Yes.
Sorry, but what are we supposed to do?
We get NPV. So we discount these certain amounts. We discount these certain amounts. Okay, from year zero all the way to year three, using discount them at the risk-free rate of return, which in this case is 7%. Okay, so cash flow times this factor, and of course, therefore we get the present value. Okay.
We multiply 0.07 times the cash flow.
No, this is the discount rate. You are discounting. This is a discount rate. Okay.
Oh, okay.
Yes, this is the discount rate, which is 7%. So you discount this at 7%.
Okay, thank you.
Okay, then you get NPV.
So I got negative 1306.
Negative 1306.
Yeah.
Okay, someone confirm that value.
What was the initial investment?
Zero, you have it here. 5,000, isn't it? This year zero.
I'm getting minus 856.
Minus 856. 856. Okay, another confirmation. You get two answers that are contradicting.
Sir, I got minus 856.
So I got
But I guess
856 too.
Okay. So great. Therefore, you get therefore a negative 856. Now, what does that mean? Should we invest? No, don't forget before we got a positive. But now the reality is that once we have done the risk incorporation, this is not a good investment. Okay. If you were to ignore risk, it was a positive. I think it was 1304. But now the reality is that hey, this is not a good investment. Okay, because there's a risk. This is a risky environment. Okay, the company should not invest in the project. The company therefore should not invest in the project. Okay, invest in the project since it has a negative NPV, an NPV of negative 856. The company therefore should not invest in the project. Okay. So the thing is that when it comes to this method, when it comes to how we can incorporate risk in appraisal of investment, you should be able to discuss this method. Okay, I haven't seen an exam asking you to do the math. Okay, behind like they have done here. Okay, but you should be able to explain them. Can you be able to explain? If you can, that shit is going very good. Okay. However, I've not seen a question being asked to how to do the math. Okay. Okay, this is good enough that you'll be able to explain well on how to get the NPV, how we appraise, okay, using the certain equivalent method. The next one we can use is called the use of the sensitivity analysis. Okay, it's called the use of the sensitivity analysis. That's the next method. Okay, now in this method, the use of the sensitivity analysis. Okay, what we do is that what you want to what you want to answer is among the different variables that can affect or do affect the value of the project. Okay, which one is going to which one is more critical? Okay, we have to use that term. Okay, which one is more critical variable? Okay, because not all variables, as per se, okay, have the same impact. Okay, we want to know among the different variables that can have an impact on the NPV, okay, which one should we take more caution, okay? In code, we don't want to mess with it, okay? Which are the more critical variables, okay? That's what we want to answer when it comes to the carrying out of the sensitivity analysis, okay? When you want to carry out the sensitivity analysis, okay, determining which variables they are more critical, okay, when it comes to the appraisal of the investment, okay? That's on this of sensitivity analysis. So you want to answer what we call, we shall attempt to answer this question, okay? That is, which of the variables are more critical? One of the way, okay, is what we call using what we call our what if analysis, okay? I don't know whether you've never, if you've done Excel, you know this, okay? Carrying out called what if analysis. If we adjust one variable, okay? If we adjust, for example, the selling price, example, the selling price, okay? If the selling price was to decrease, okay, by let's say 10%, we observe what happens therefore to the NPV, okay? And here we are going to be changing a variable at a time, okay? So in case the selling price increase, all the other variables remains constant, okay? So in case we increase the selling price by 10%, we decrease the selling price by 10%, what happens to the NPV, okay? In case we increase the variable cost by 10% by the same rate, what happens to the NPV, okay? For example, if we increase the variable cost per unit, okay, by let's say 10%, we observe what happens to the NPV. Assume the change in NPV will be a decrease, okay, there'll be a decrease by let's say by $102, okay, just an example. In case we decrease the selling price, okay, by the same percent, 10%, we observe what happens therefore to the NPV. It will be decreasing by let's say 503, okay. In case we increase the fixed cost, okay, by let's say the same rate, 10%, okay, what happened there to the NPV? As in the NPV will decrease by let's say $52. Here's an example. So we determine therefore among these three variables, which one is more critical? By the which one is more critical among these three variables? Variable cost, selling price, and fixed cost. Which one is more critical?
selling price.
Selling price, of course, selling price, because for the same increase, for the same percentage change, it has more impact on the value of the project. Therefore, is the most critical variable in this analysis. And the least critical analysis is therefore the least critical variable is therefore fixed cost. Okay, that's the use of sensitivity analysis. Okay, now
Or is it the same?
Sorry?
Sorry. Is it the same when NPV increases with the most value?
Yeah, the same. Okay, the same thing. Okay, that we alter our variable, we see how the same thing because we want to see how sensitive is the project. Okay, in terms of its NPV, if we alter the variables. Okay, the same thing. Okay, it also be increase. Okay, it also be the case of also the increase. Okay. That's on the same margin. But generally, don't forget what that would mean. Okay, if for example we go back to the question you've just been doing, like for example, the BQK company, if the selling price, if you have to increase the selling price or decrease the selling price, okay, then that means therefore you need to get you need to do another analysis somewhere. Okay, so it means therefore if we change a variable, then need to get another NPV. Okay, and you can remember the has to go through together NPV. Okay, if we change another variable, then another NPV. So in case you have 5 variables, it means you'll be doing 5 NPV analysis, which is a lot of work to do. Okay, it's a lot of work to do that for sure. So what we do is that we use a margin. Okay, we use a margin. Okay, and the margin tells us that by how much must this variable increase or decrease to make the NPV equal to 0. Okay, we use a margin. Okay, and this margin, what it tells us? Okay, this margin, it tells us that in case the variable sorry, my pen today is misbehaving. Anyway, so in case we do increase the variable, okay, by how much must we increase either the variable or decrease the variable to make the NPV equal to 0? So we use what we call a margin, okay, and the margin is giving us the net present value of the project under the current condition without any altering, okay, the NPV of the project under the current condition without any alteration. We divide the present value of the variable at a constellation. If, for instance, of course, you can express that as a percent, okay, you express that as a percent, okay. So if, for instance, we get the margin to be, let's assume that you are analyzing that's the variable cost, okay, and we get the margin to be, let's say, 8%. That will be the margin. Then what does it mean? It means that in case we do increase the variable cost by 8%, in case we increase the variable cost by 8%, the NPV, I'll see that currently the NPV is, let's say, positive, let's say 1304. Okay, in case we increase this variable cost, okay, by 8%, then the NPV will decrease from 1304 to 0. Okay, to decrease to 0. Would imply therefore, if the variable cost increase by further more than 8%, let's say at 9%, then we end up with a negative NPV. So the margin tells us by how much must this variable change by, okay, what's going to be the change in this variable, okay, that is going to make the NPV to become 0. Okay. If we get, for example, the margin for selling price, okay, to be 30%, then that means therefore that we can increase or we can decrease, okay, the selling price by 30% before the NPV becomes 0. If we increase further that, if we increase by that 1%, then the NPV becomes a negative. Therefore, the use of the margin, okay, is giving us the NPV under the current condition. Before you make any alteration, you divide by the present value of the cash flows under that variable, under the variable you're considering. Okay, selling price, variable cost, okay, fixed cost. So all those variables, okay, that can have an impact, okay, on the NPV. You determine them. How many are they? They are, for example, selling price, variable cost, fixed cost, initial cost, okay, scrap value, working capital. So all those variables, okay, all those variables determine what is their present value. Okay, if it's about working capital, get the present value of working capital. Okay, once you get the present value of the working capital, okay, you therefore NPV divide by the present value of those working capital, we express a percent. And what's the margin? By how much must that variable increase or decrease to make the NPV of this investment equal to 0? Therefore, between these two variables, the variable cost here, okay, and the selling price here, if their margin is 8% and 30% respectively, which one is more critical variable? Sorry, which one is more critical?
Selling price.
Don't forget, let me repeat, the selling price need to decrease by 30% to move the NPV from 1304 to a 0. The variable cost need to increase by 8% to move the NPV from 1304 to 0. So which one is more critical? The selling price or the variable cost?
The variable cost.
The variable cost is more critical because it only needs a small change to make the NPV to become zero. This is 30%. This is a huge change. You have more margin here. Here is only 8%. And implies, therefore, the variable cost in this example is more critical than the selling price. So as a manager, pay more attention to the variable cost because a small change in the variable cost has a huge impact on the NPV. You get it?
Yes, so it means if there is a smaller difference, that's more critical.
Yes, the one that has the smaller margin. Okay, the smaller the margin, the more critical that variable is. Okay. Don't forget the change is the same. The change is from that is your 4 to a 0. Okay, that is your 4 to a 0. Both of them. However, here there's more margin. Okay, you have that is that percent decrease. This is 8%, only 8% to make the same change. Okay, therefore, this is more critical variable. Okay. Great. Okay, let's do an example. So go through this, then we attempt to read together. Okay, in this example, we want to determine the sensitivity of the variables of the NPV towards a change in those variables. Okay, so cost as what happened here? Sure, what has happened? Okay. Hmm. Okay, so first is to identify the variables in question. Here I can see this initial cost, variable cost. I want to suppose that the cash inflow represents, of course, the revenue. Okay, then we have, what else do we have? In the cost of capital, we have the number of units. Okay, the selling price. Yeah, okay, that's the first step. Identifying or determining the variables that might have an impact on the NPV. So let's begin the first one, selling price. Okay. So let's begin, we get the margin for the selling price. Okay, so the sensitivity margin, as you mentioned, is given us the NPV before any change is made or before any alteration. We do a present value of the variable at a constellation, and of course we express as a percent. So the first step, get NPV. Okay, what's the NPV of this project? That we can do in 2 seconds. We got the cash inflow. The cash inflow is 4,500. 4,500 times present value and factor 2 years, cost of capital is 8%, minus initial cost, which in this case is equal to 10,000. Therefore, the NPV for this project?
1023.5.
1020?
3.5.
Okay, therefore get $1024 with NPV positive. Is that positive?
Yes.
Okay, therefore get 1024 to be the NPV. Okay, so therefore we want to determine the margin. Okay, by how much must we increase or decrease the variable to make this NPV to be equal to 0? Okay, let's begin the selling price. Okay, the first variable is the selling price. Don't forget, you can't get the present value of a selling price. What do you use instead? Brian, what do you use? You can't get the
Sorry?
you cannot get the present value of a selling price, so you have to use something else instead. And what do you use?
You cannot get
The present value of a selling price. Or can you? You can't. You can, but when it comes to the entire project, because okay, it has to be for the entire project. Okay, what are you going to use instead? When it comes to get the present, don't forget the variable you are trying to analyze is selling price. Okay, however, you can't do that. You have to get the selling price is per unit. But what therefore do you use instead when it comes to getting how sensitive is the project towards a change in the selling price? What do you use instead? Because you can't get the selling price of $10 as it is given here. No,
I'm
here.
not too sure.
This is sure.
Huh?
Okay. Okay. Sanya, what do you do?
Variable cost.
That would be another variable.
Oh, selling price.
We use the sales revenue. Use the revenue, isn't it? Don't forget, in case the selling price is increasing or decreasing, it will have an impact on the selling price, on the sales revenue, on the revenue. Therefore, you can be using the present value of sales revenue. Okay. Therefore, so get is revenue here because the total value to be saved from the sale of an item is the revenue, because the revenue per item is referred to as the selling price. The revenue per item is referred to as the revenue. Hope you understand that. And here the revenue, okay, therefore is like the cash inflow here, which is equal to 6,500. Therefore, we get the present value of revenue. Therefore, 6,500 times present value and factor 2 years, 8%. And you get how much? 11. I'm guessing. So I'm not sure that is 11.
Uh, 11,590.
1159 can afford the present value of the revenue. Okay. Now get the selling price is the revenue per item. Therefore, total will be sales revenue. Okay. Therefore, the margin therefore will be equal to, and the NPV 1024 we divide by the present value of the variable 11,590, and you get how much? You extract this as a percent.
Excuse.
Mm,
How did you get 11,590?
the present value here from here.
Is it 1.942?
I am not sure. 8%, 2 years, 8%. I don't know. I don't have the table with me. 6,500 multiplied by the value by the table.
It's okay.
It's okay.
Yeah, I've seen the issue. Yeah, thanks.
Okay. Therefore, and you get how much the margin?
8.8%.
8.8%. Now, what does that mean? It means therefore, in case we decrease the selling price, don't forget why it decreased, because this is already positive. Therefore, this is already a positive. That's why you're decreasing. In order for us to decrease, if we decrease the selling price by 8.8%, then we're going to be getting a zero NPV. That's what it means. If we decrease the selling price by 8.8%, we get a 0%. If you decrease it by 10%, for example, or it's 8.9%, then we get up with a negative NPV. Okay, that's the margin of the selling price. Okay, the next
So
variable.
could you please repeat again?
If we decrease the selling price by 8.8%, then we're going to end up with a zero NPV project. If we decrease it further by, let's say, 8.9 or 10%, then you're going to end up with a negative NPV. Clear?
Yes, thank you. And another question, like for every change in variable, like let's say selling price or variable cost, do you have to do it separately for every?
For every variable?
Yeah.
Yes, you have to do. For every variable, you have to do it. Because here we are making an assumption that every variable, in case you're going to be changing the selling price, then all the other variables remain constant. Okay, the number of units for sale, cost of capital, they remain constant. So you only change one variable at a time. Okay.
Yes, thank you.
Okay, the next variable is the variable cost. Variable cost per unit. Okay. So in this case, what do you use?
The variable cost.
Of course, the variable cost, the total variable cost. Okay, the present value of variable cost, therefore be equal to given to us as 4,500. How much is it?
2,000.
2,000. Therefore 2,000 times present value and factor 2 years 8%. And you get how much?
3566.
3566. Therefore, the margin will be equal to NPV 1024. The present value of the variable 3566. We express this as a percent, and we get 20 or 30.
29.
29%. Okay, therefore the margin for the variable cost. That is in case we increase the variable cost by 29%, then we end up with zero NPV. If we increase it further, then end up with a negative NPV project. Okay. The next variable can be on initial cost. Initial cost, therefore, we get the present value of initial cost. This is very straightforward. Okay, the present value of initial cost. Do you even get it? It's already in present value terms. Well, this is year 0. So you don't even discount it, actually. Because it's already in year zero. It's already in present value term. Therefore, the margin for initial cost will be equal to NPV 1024 divided by the present value of the variable, okay, which is equal to 7,000 and excess as a percent. To give us how much?
15%.
15%. Okay, 15%. Okay. Therefore, the margin that in case we increase the initial cost by more than 50%, which you can try, because I think this one is a bit easier straightforward. Let's increase the initial cost by 15%. I guess it was 14 point something, isn't it? It was 14 point something.
I was 14.63.
14.63. So in case, let's increase, okay, just to see whether that will be the case. Let's increase this by 14.63. Therefore, it will be equal to 114.63% times 10,000. What do you get? With the new initial cost after we increase it by that margin.
Uh, 8,024.
8,024. Then you minus, this is the initial cost, minus the present value. So the present value of cash flow, we got to some, where was it? When we get in the NPV, we got to somewhere. Yes, here it is, okay. So instead of minusing 8,000, what if we minus now 8024? I guess you get a zero, I don't know. You do get a zero? The present value of cash flows minus now our new initial cost.
-18.5 negative.
18.5.
Yes.
So negative 18.5. Okay, more or less it's close to a zero. Okay, it's close to a zero. Okay, I guess negative 18.5. Okay, that's what we mean by the margin. Okay, that in case we are to increase it further by a given percentage, in this example, 14.63. Okay, or 15%. In case you use 15%, then you get end up with a negative. We're going to end up with.
Sorry, it's negative 0.5. Sorry.
So it's negative
0.5.
Negative 0.5. Yeah, you can see, so it's very close to zero. Okay, it's zero. Okay, that's what we mean by the margin. That in case here we increase the variable cost, the initial cost by more than 14.63%. Okay, then we get up with that zero NPV. If we increase it further, then it becomes therefore a negative. Okay. That's on the initial cost. What else can I do? There's another variable here I can do, which could be, there's no working capital in this question. What else do you have? The number of window of sale. Here is the selling unit, the sales units. Now, in this example, the units of sale, what do we use here? How to get the present value of the units of sales? It's easy. This one is easy one.
The units.
How do you? They're not in dollars.
Sales revenue.
Sales revenue, but not that to be the selling price, isn't it? The selling price here.
Isn't it selling price?
If you do the selling price, it means you're trying to evaluate the sensitivity of the selling price. If you use the revenue. Sales units.
Cash inflows?
Sorry?
Cash inflows?
The cash inflows, in this example, which this
okay, wait, outflows.
The cash?
Outflows. No, wait, inflows.
The inflows is the revenue in this example.
So we don't use revenue for sales?
No, you've done that for the revenue. If you do the revenue, it means you're analyzing the sensitivity of selling price.
Oh,
Uh,
So what do you use here?
Profit.
cost.
Which cost? Variable cost or which one?
Initial cost.
Initial cost, you have it here already.
Purchase.
Sorry? You use contribution. Hey guys, use contribution. Don't forget contribution affects the revenue and the variable cost, does it?
Yeah, I was about to say contribution.
Yes, we'll get the contribution. So in this case, therefore, we get the present value of contribution. Okay. So present value of contribution, therefore, which in this case is revenue minus variable cost, which in this case is equal to 4,500. Okay, 4,500. Present value factor. Okay, 2 years, 8%. You get how much? 8024. I think I remember. I don't know. 8024.
Yes.
8024. Okay, therefore, we go to 1024. We divide by 8024. Gives how much? 12 points.
12.76.
12.76. Okay, 12.76. Call therefore the margin. Okay. And lastly, cost of capital. The cost of capital can also affect the NPV. So by how much must the cost of capital increase by to make the NPV to go to zero? Can you do that? As our last variable there. Okay, do that in the next 2
Excuse, could you show the question again? Okay, that's
Hey guys, what do you get?
Sir, I got 18.55%.
That's be what was that? 18.55?
The cost of the IRR. I calculated the IRR.
Yes, that's be the best way. That you get the IRR. Okay, the IRR for this.
Okay.
Yes, that's the best way to do it. Then you get.
So, but you have to keep trying to figure out the rates because it took me a while to figure out as well. I used 15 and 20%.
But you can use Excel, isn't it?
Oh, I didn't use Excel. I should have thought of that.
Yeah, Excel is going to make your work very easy.
Okay, okay.
Yeah. And the same applies in your exam. Okay, in case, for example, you have a question in section, I don't know, section A, section B, that asks you to get IRR, you go you can go straight to section C. You pick Excel from section C. Go to get the Excel will be in section C. Then you put your workings there. Then of course after the workings you delete. Then you come to section A, section B, and you have the IRR there already. Anyway, so for example, we can do that quickly here. So the cash inflows as follow. For 500, they were for 500 each year. So first there was year 0, negative 7,000. Then 500, 4,500. Then what to get IRR? F equal to equals IRR. Then I define my cash flows year 0 there to year 4, and you get 18.52%. Okay, therefore to be the IRR. The cost of capital is currently equal to 8%. 8%. Therefore, the margin. Therefore, we can say the increase in cost of capital, okay, that will make the NPV equal to 0 will be equal to, okay, equals 18.52 minus 8, okay, and of course we divide. Therefore, you need to put the brackets here, okay. We divide by 8 because we want to get the percentage change, okay, and you get therefore 1.1%, therefore to be 1.2%, therefore to be 1.55%, therefore to be the margin. That we need to increase the cost of capital from 8 to 18.52, which represent 1.55% margin. Okay, is that clear? Brian is clear, Nafisa?
Yes.
Okay, great. Yeah, for the margin, therefore, is equal to 1.55%, an increase from 8 to 18.52%. Okay, therefore, among these variables, okay, the critical question was to answer among these variables. Let me go back to the question. So among, where is it? No. So here you got 1.1. So the cost of capital, you have gotten to be the 1.55% base margin. So we want to determine which is more critical. Of course, the one that has the lowest margin. In this example, selling price I think has the lowest margin at 8.8%, 8.8%, followed by this one we got 12%, followed by this number of units of sale, okay, followed by the initial capital, okay, followed by the variable cost, and lastly, the least critical variable is therefore the cost of capital at 1.55%. Clear? Okay, great. So that's on how to get on the days of the sensitivity analysis of the sensitivity margin. Okay. Okay. Next is the next method we can use is the use of the probability analysis. The next method is the use of the probability analysis. Okay. So in this method, okay, just like the way we did with the case of the certainty equivalent approach, this time around we are going to be getting, as we mentioned, they're going to be getting more than one outcome. Okay, you're going to be getting more than one outcome for the same set of events. Okay, for the same projects. Okay, or you can get, for example, 10 million. So, for example, in year 1, you can get a cash inflow of either 10 million, or you can get a cash inflow of 15 million. For example, in case the market is doing normal, if it is doing very well, that's what you'll be getting. All the chance you're going to be getting 10 million, maybe 0.4, or the chance of getting 0.15 million, 0.6. Okay. Therefore, based on these two outcomes here, 15 million and 10 million, we can get the expected values. Okay, because this is what you can get. Okay, 40% of the time you'll be getting 10 million, then 60% of the time you'll be getting 15 million. Then combined wise, okay, those two events, okay, what is the expected value? Will be equal to 10 million times 0.4. We get therefore 4 million. 15 million times 0.6, and again we get 8 million. Therefore, combined wise, okay, the expected value from year 1 is therefore 12 million. We do the same for year 2. Okay, the same for year 3. Again, you get every year you do get the expected cash flows. Once you have the cash flows from year 1 all the way to the nth year, discount them back to year 0, okay, and you get the NPV. Therefore, this will be an expected NPV value. Therefore, once you have the expected NPV value, you can make a decision, should we invest or not invest in the project based on the expected cash flows, based on the expected cash flows. And that's the use of probability analysis. Clear?
Sorry, could you repeat after like the process again? Sorry.
Okay, so you'll be getting a series of outcome. Okay, you'll be getting, for example, in year 1 you can get 10 million or you can get 15 million. Now, what the chance of getting 10 million is, for example, 0.4. Or what the chance of getting 15 million, 0.6 at the time. Therefore, what therefore is the expected value, the expected cash flow in year 1 is simply the outcome times the probability. Outcome is 10 million, probability 0.4, and you get 4. Then the next outcome, 15 million times the probability, 0.6. The 15 times 0.6, okay, I'm not sure whether you get 8 million, I don't know, I was just guessing here.
9.
And you get 9, okay, so here you get 9.
Yeah.
Okay, therefore you get 9. Therefore, the outcomes, so all the outcomes, type plus outcome times probability, you add them all together, okay, from the first outcome all the way to the last outcome. In this case, there are only 2 outcomes. Therefore, 9 plus 3 to give us, therefore, 13 million. That's for year 1. The same for year 2. The same for year 3. The same process for year 4, all the way until the end of the year, okay. Therefore, we'll be having expected cash flows. Once you have those expected cash flows, discount them back to year 0. Then the normal way you get NPV. Okay, discount them back to year 0 using the company cost of capital, and therefore the NPV you'll be getting is an expected NPV. Okay, and based on it, you can make an advice: should we invest or not invest in the project? Okay.
So if we had 4 different outcomes, we would add.
You'll be adding 1.
We would add the 4 to get the expected NPV.
Yes, so you'll be adding, for example, 3, 4. Okay, the 4 you have here, plus this is 6. Okay, for the next outcome, and plus 9. Then you add all of them together for the expected cash flow for year 1. If they're 10, the same thing. You have to do 10.
Okay.
Okay.
Yes, thanks.
That's the use of probability analysis method. Okay. You can also have the last method. Okay. So I think I can leave you to do this. Okay, it's a very easy question. The best is in case you do it through a tree diagram. Okay, I hope you've done this already. But okay, but for this question, don't worry about calculation. Okay, about calculation, don't worry. But you'll be able to explain. Okay, so let me first go through the Monte Carlo. Okay, but don't worry about Monte Carlo. So for the Monte Carlo, this is called Monte Carlo simulation, or simply simulation analysis as our last method. Okay. Now here, what we do is that we simulate the outcomes. Okay, what we do is that we assign or refer to as the random numbers. Okay, to the outcomes. Okay, for example, in this, let me just go back to the previous example you've just done. Okay, allow me to do that. In this case, we had two outcomes. Okay, 10 million. What happened? Yeah, 10 million here. Yeah, 10 million and 15 million as outcome. Okay, so based on this outcome, okay, we can say we have outcome for year 1. Outcome for year 1, you have 10 million and you have 15 million. The probability was 0.4, the probability was 0.6. So what it is that we can assign numbers, what we call the random numbers. Okay, these are random numbers. We can say that if we get a number between 0, 0, all the way to 39, these are 40 numbers, or between 0, 0, 1. Okay, I think that we begin with 1 to make it easy for you to understand. If we can begin from number 1, 0, 1 to all the way to number 40, if you get a number between 0, 1 and 40, then we are going to say that the outcome for year 1 therefore will be 10 million. if you get a number between 41, okay, and 100, which are 60 numbers, then we are going to assume the cash flow for year 1 will be 15 million. For example, one of the generator can use, okay, one of the generator that can help you out in getting to know what the numbers are. Excel can act as a generator. For example, let me go take it to Excel, okay, to show you how it can help you in generating those random numbers, okay. For example, so I want to generate a random number here, okay. So I say equals. I want a number between 0, 0, 0, 1, okay, a random number, okay, this is a random number between, okay, 0, 1, all the way to 100, all the way to 100, okay, I get 51, okay, so just define the number between, so here it is, between 1 and 100, okay, so therefore I get a number, okay, of course I'll get a different number now this time, so we get 53, okay. So since it has given me 53, then when doing my calculation, year 1 cash flow will be the number with the cash flow between that has a number between number 53. For example, let's go back to our analysis, our question here. So here 53 is between, okay, between 41 and here it is. It's between 41 and 100. It's here. Okay, which means that for year 1 cash flow, 15 million. It is the same for year 2. Okay, year 2. What are the outcome? Can be, let's say, 13 million and 8 million. All the probability 0.3, 0.7. Okay, it's the same. Assign number 0, 01 all the way to 30, 31 all the way to 100. Then you can throw a dice, okay, like through a generator. Okay, therefore you're going to go for a generator to give you the numbers. Okay. Let me go back to the generator, our Excel here. I'll give us a second number. Let me just drag the formula. Of course, give me a different number. I get that 4, okay? Therefore, that 4, where is that 4 here? 34, where is this? 34 is between, here it is. That 4 is between that 1 and 100. Okay, therefore in year 2, the cash flow will be 8 million. Therefore, year 1, I got 15 million. Year 2, I have obtained 8 million. I do the same for year 3, for year 4, for year 5, all the way to the end of the year. Then I get the NPV. These are cash flows, year 1, year 2, year 3, year 4, then get the NPV based on the cash flows that have been generated from the simulator. In this case, from the random number generator, from the simulation, okay? Then get the NPV, okay? That's the first step, okay? That's the first NPV. You repeat the same process, okay? And as many times as possible, okay? If possible, if you can do for 100 or 1,000 NPVs, they're better off. If, for instance, you do 22 NPV, this is NPV number 1, you repeat the same process, okay, two times, okay? You also get another NPV. Because you'll be having 2 NPVs, then you can get an average NPV based on the 2 attempts that you have made. Now, based on the average NPV from those 2 attempts you have made, then you can make a decision as to whether to accept or reject the investment. Clear? Of course, this is going to be taken out of time, okay? That's why you normally prefer to use the computer, okay? The computer is going to help you be able to determine how you're going to be getting, to help you out, okay, in getting this average expected NPV. Because 2 times is not going to be the best optimal, okay? So if possible, you should do to 1,000 times, okay? Therefore, you can't do this manually. So the computer can help out in being able to determine what ought to therefore to be the expected NPV based on the average NPV value obtained from the individual NPV analysis that you've just seen above there. Clear, Nafisa?
Yes, sir.
Okay. Brian and Sanya, clear?
Yeah.
It seems a bit complex, but I'll go through it again.
It's not complex per se. Don't forget it should be able to explain. Okay, it's not very complex. It's very easy, by the way. Or it's quite easy.
We can get a question to do it.
There's no question that the examiner has ever tested this area, so you should just be able to explain it. Yeah, that's what
okay.
I was telling you. The examiner is not going to ask you to test these questions, but you should be able to explain them. Okay, that's the idea here. You should be able to explain these methods.
Okay.
Okay. And great. Those are them 6 methods. Yes.
But by explaining, you mean that we have to explain how to get the answer, like how to get the NPV.
Yes, the idea is that you should be able to explain that you don't know what is a simulation analysis method. Okay, so in case you want to look at it from that angle, then fair enough, it's okay. Or even if you want to follow the notes here that I've given here, it's okay. But you should be able to show the examiner you understand what we mean by a simulation analysis. Yes, you can also explain on how to get the NPV. You can do that.
Thank you.
Okay, great. So you should be able to explain. That's the idea here. You should be able to explain these methods. Okay. And those are the 6 methods you can use when it comes to how to incorporate risk, okay, into the project appraisal. Okay, from the past, from the past exams, and this is from 2007. Okay, that's for the last 14 years. Okay, what I've seen the exam trying to do is that you are given a question. Okay, discuss 3 methods you can use in project appraisal in order to incorporate risk. Okay, 3 methods. These are 6. Okay, so you choose the one that you think it's easier for you to be able to explain. If you find it easy to explain simulation, then pick simulation. But the one that you are comfortable in explaining. Okay, that's what I've seen the examiner asking. Okay, which I think we shall look at it the next time we meet. Okay.
So,
yes.
Can we please do the illustration on probability analysis, please?
This one. This question.
Yeah, that one.
This one is going to take years for us.
So also, what is joint probability?
Joint probability is the chance that 2 events can occur together. That will be by joint probability. 2 events that can occur together.
Do you have any questions that involve joint probability?
There's one on cash flow. Okay, it was more towards cash flow management, which I think that would be better for us to do.
Okay.
So I think on Monday, remind me to do that question.
Okay.
It's on cash flow management. Okay.
Okay.
Joint probability. Yeah, I think we can do that.
Okay.
Okay, so on Monday, remind me to do that. Yes, Nafisa.
Great. So for all these methods that we've done, it's just the explaining part you're supposed to know properly.
Yes, it's just the part of
Like
explaining.
there won't be any calculations.
No, there won't be any calculation on this method. No calculation at all. But you never know.
Thank you.
It's good enough you know how to do a calculation. You never know. But I don't think the examiner is going to ask you to do the calculation on it. That is based on experience for the past 15 or so years. Okay, so that's on those 6 methods. Okay, on those 6 methods. Okay, if there's no question, then I guess we can meet on Monday next week. Okay.
So,
yes.